All right, so we're doing rate in, rate out. So our big key concept today is that the integral of the rate gives us the change in the total amount. And so key there being the word change. So when we take the integral of the rate, we'll get the amount, and technically it's the amount at time B minus the amount at time A. So we can set up a general formula for this by saying that the amount at any number time is equal to the amount at A plus that integral from A to that number. And we can change that number to be like a T, right? And that'll give us a formula. So usually these will give us a rate in. Sometimes that's all they give us. Other times they'll give us a rate in and a rate out. And so then we can say that the total rate is rate in minus rate out. So we'll kind of just set up some terminology so we can talk about this. So if we had the rate into a bathtub where E of T is our rate in and L of T is our rate out, and they want to know what is the amount of gallons that just enter, right? Then we're just going to use E of T because all we want is enter. We just want the change, right? If they said that there were 10 gallons initially, we don't care about that. They just want the change. Now, if instead they ask us how many gallons are in the tub after 2 hours, that's a total. So now we need everything. We need the amount going in, we need the amount coming out, and we need to consider that 10. So this is where we're going to use that formula. And I want to separate these. We'll see why in a minute. But I want to separate the integral. So it's 10 plus the integral of the in part minus the integral of the out part. And then if you had equations, you would type those into a calculator. Now, they might ask us, is the amount of water increasing or decreasing at some time too? And as soon as we see the word increasing or decreasing, we're going to take the derivative of that. So the derivative of the amount gives us the rate. So there's the formula. I've seen them also ask, is the rate of water in the tub increasing or decreasing? Now we're going to take the derivative of the rate because increasing tells us to take the derivative of that. So the rate was E of T and L of T, so we're going to take the derivative of E of T and L of T. So E prime of T minus L prime of T. So we have two things that they could ask us: average rate of change and average value. Average rate of change is the average rate of what they want. So it's the derivative of what we want, whereas average value is kind of, we're thinking the same. So they want the average of f of x, they give us f of x. On average rate of change, maybe they want the average of f prime of x. So it's the average of the derivative. So if we have E of T minus L of T as our rate, if they want the average rate that water enters or leaves the tub, we're thinking, is it average rate of change or average value? Those would be the formulas. But because we're given average rate and we have a rate, we want to do average value because it's kind of our same thing. So we're going to jump into a couple examples here. Some keywords, right? Customers remove bananas, and then they give us these intervals from 0 to 12. And then at time 3, they start adding bananas. So this is important. The adding part is only from 3 to 12. Now part A says how many pounds of bananas were removed during the first 2 hours. We don't care about that 50 because all we care about is how many are being removed. If we look at that word pounds, we know we're going to need to take an integral. So it's the integral from 0 to 2 of f of t dt. Okay, part B, it wants us to find f prime of 7 and then using correct units, explain the meaning. So a lot of us did kind of get messed up with the explain the meaning. We need to be careful about that. I was just showing there that we can, in our graphing calculator, enter those as f1 of x and f2 of x to make this a little easier so we don't have to retype it every single time. So anyways, we take the derivative of this and we get that 8 point something number. And just reminder that when we take the integral, we're going to chop off time. When we take the derivative, we're going to add on time. Since we're taking the derivative here, we need to add on a per hour. Now, we need to explain this. This first thing is just us talking through it. Like, this is the rate of the rate because we're taking the derivative of the rate. So that's kind of us thinking. Now, when we're going to explain it in the context, we want the second part. The rate that bananas are removed at time 7 is decreasing by 8.1195 pounds per hour. So key there, we need the word rate, time equals 7, and then that last part. Next, it wants to know, is the number of bananas increasing or decreasing at time 5? So the number of pounds, that's the amount. Is the amount increasing or decreasing would be the rate. So our total rate is going to be g of t minus f of t, right? We're past 3, so it has both. And when you subtract them, you get negative 2.2631. That's less than 0. We need that, so it's going to be decreasing because g of 5 minus f of 5 is less than 0. And D asks, how many pounds are there at 8? This is the total. What is the total amount at 8? So this is where we're going to do that general formula. A of 8 equals 50, which is our starting point, plus the integral from 0 to 8 minus f of 8. Of g of t minus f of t. I made a mistake here. I was asking the class to find the mistake. And the mistake is that g of t is not at 0, it's at 3. A lot of people miss this question because they always just assume it's at 0. But in this case, you can't combine them because they're at different points. So g of t is adding only from 3 to 8, and f of t is subtracting the whole time. All right, we're going to move on to example 2 after this. But yeah, here we go. So this one's about water in a tank. It starts off with 40 gallons. It goes into at that rate W and leaks at the rate L. So I'd recommend typing these into our calculator as F1 of X and F2 of X. We're going to go through this example a little quicker. We're just going to talk about how we would type these into our calculator. So just going into is the integral from 0 to 2 of F1 of X. Part B, when we see minimum, that's like we're doing that table. So first is we need to take the rate and set that equal to 0. Make sure that on the calculator we use that at 0 less than x less than 2. And we'll get x equals 1.5808. By the way, on the calculator, even though it has t's, we're going to be using x's for our calculator for the graphs. Now that we get that value, we're going to put it into our table. The initial is 40. And for our other 2 points, we need to set up that integral. The integral from 0 to time of w of t minus integral from 0 to time of L of t, and then we add on the 40. So for those t's, right, we're going to put in 1.58, and then we'd put in 2. I'm going to write how it would look putting in 1.58 on your calculator. For 2, after you would enter, you would just go back up, copy paste it down, and change the 1.58s to 2. So a few people got this explanation part wrong on the test. They did the entire table right, but they messed up their explanation. So an easy way is to just put both, right? The minimum is 33.424 gallons at time equals 1.58. If we write down both of those, we can't get it wrong. Okay, C wants to know, is the amount of water increasing or decreasing? So kind of a way to do this is to write A prime of T equals W of T minus L of T. It's just the same thing as total rate, right? The total rate is W of T minus L of T. In our calculator, we would just type that in that way. We get negative 3.9891. That's less than 0. So it's decreasing because W of 1 minus L of 1 is less than 0. All right, and D is kind of a funky one. We saw this on our test. It's a little bit different because they say that for time 2, greater than 2, it's still going in at W of T, but it's now leaving at 1.02. So before we had, well, we want to find out when does it hit 300. So before we had 40 plus integral from 0 to T of W of T minus L of T. But now we're no longer starting at 0, right? We're now starting at 2. So now we want to change this to be starting at 2. So instead of 40, we're going to go back up and pick 35.8 because that's where we started at 2. And it will go from 2 to W. W of t stayed the same, but L of t changed to 1.02. And that's our formula. They don't want us to solve it, but we do need to make sure that we change it to be equal to 300. That's what they would want us to solve for, is when it is equal to 300. So this question's kind of standard, and as a kind of weird part D that they'll ask, but once you get the hang of them, they're not too hard. Okay, now we're going to jump into our homeworks. So going over the homeworks, question 1 on the homework was talking about cars, and you can either look at the answer key they gave you, or you can look at the one I'm going to present. But kind of looking at this, part A asks how many cars pass through it. So it's just a basic integral. Part B asked about the traffic flow. Is it increasing or decreasing? And they want the flow increasing or decreasing, right? So flow is already the derivative. They want us to take the, or is already the rate. They want us to take the derivative of that because we see that word increasing, decreasing. So then C and D are average value, right? They gave us average value, so it's kind of obvious. Now with those units, when we do average value, the units stay the same. And on D, when we do average rate of change, we need to add on a unit. Okay, second question. Okay, the first one was just the integral, right? So we just did the integral because it just wanted the amount entering. Then for part B, it wants that is it increasing or decreasing, so we just plug in 6 and h of 6 minus r of 6, and we get a negative answer. For C, we are going to do a of 12 equals a of 0 plus the integral minus the integral. I separated them. You wouldn't have to. And then on, since it said how many gallons, we don't necessarily need to include units, but we can. Looks like the video jumped ahead, but oh, there we are. Okay. And then on D, we're gonna set this equal to 0. So on our calculator, that's how that would look. We have 4.790 and 11.318. On the AP exam, they worded this answer really weird. I would just leave it with the table. We've been doing the table. It's nice and easy, and that's how we would do it. So to get those answers in the table, what you do is you just change that number 12 from part C to 4.790, and then you change that number 12 to 11.318, and that's how we get those answers. Okay, the last one is a little bit tricky. This is like, to me, this is just the worst question. It's one of those ones where it's just way too hard. But when we look at B, I kind of gave everyone a hint, is that they want the maximum of the rate. So not the maximum of the people, but the maximum of the rate. So we're setting R prime, not R equal to 0. So A should have been kind of straightforward. It's pretty easy. Just take the integral. B is where it gets weird. We're going to take the derivative. We set that equal to 0. We get a time. And then we're plugging those into R of t because we wanted the maximum rate. So we're plugging those back into like R of 0 equals 1380 t squared minus 675 t cubed at times 0. And then we do the same thing for those other numbers. C is fundamental theorem of calculus. When we see that W of 2 minus W of 1, we want to think that's the change. So that's the integral of its derivative from 1 to 2, right? If we took the integral of W prime, we'd get back to W. And because we have 2 and 1, those are our endpoints. I kind of rewrote this as 2 minus t times 1380 t squared minus 675 t cubed. Now, Brisa had a good way of doing this that works as well, where she just took the integral without endpoints, and she typed that into her calculator. You get this. Don't forget there would be a plus c. because we don't have endpoints. But we have this answer without endpoints, and we could actually do W of 2 minus W of 1, because we're going to get some number plus C and then some number minus C, and the C's will cancel out. Either way, I'll get you the points. Now, D is just funky. I hate that they asked D, but I wouldn't even bother memorizing this, because really most of the time when we do see the word average, it's either average value or average rate of change, and this one is just different. So they asked us for the average wait time, right? And they had defined wait time as W of T, and then they gave us W prime of T. So as a reminder, average rate of change is when you have right, you have W of T and you want W prime. Average value would be we have W of T and we want average W of T. Well, they want average W of T, but we are given W prime. It doesn't fit into there, right? It just doesn't work with one of those. So in life, since we were little, taking the average, we add everything up and then we divide by the total. In part A, we got that the total people was 980, right? If we added everything up, that would be the total wait time, which is W of 2. To get W of 2, you would just take the integral, right? So when we add it all up, that's like taking the integral and then we divide by the amount of people, which was 980. I know that's weird. Honestly, if the first two questions were like, you understood them, the third one you didn't, it's really fine. That third one was just way too tricky and weird. So really focus on those first two. If you guys have any questions, email me or post on the classroom.